Okay, for our lab, we decided to try and test what the vortices would look like from 5 different types of frisbees. On the far left, we have a kind of standard, just promotional frisbee that we got from somebody. And then the 3 here in the middle are disc golf frisbees. The one on the left is the putter, the mid-range, and then the driver. And then we were curious to see how the Arobi disc would perform. It's advertised as one of the farthest thrown objects. So we wanted to see how that would look and how the smoke would behave during our testing. You'll notice the cross section varies in thickness for all of the frisbees. So we imagine that that will be a contributing factor to how the vortices form and how big they are when we throw them through the smoke. Okay, well, after performing our experiments with the different frisbees thrown through the fog machine, we noticed a couple of interesting things. We noticed that there was little wingtip vortices that formed on the edges of our frisbee as it traveled along its trajectory. And after doing a little bit of research, we found out that because of the pressure being high on the bottom and low on the top, when the air came over, it would wrap around and make those little vortices on both sides of the frisbee. And we noticed that the vortices, after being formed, would travel in a downward direction. After doing a little more research, we found out that when a vortice is formed, it kind of affects the fluid all around it. So if there's a little fluid particle that's at a distance r away from it, it will move or have the force acting in a tangential direction to the way that the fluid is rotating. So in the case when you have 2 vortices, one going clockwise and one going clockwise and one going counterclockwise, they're both a distance away. Each will have a net effect of pushing the other one down, so both will travel downward. So it was cool to observe that in our